All right, Algebra 2. This is Complete the Square Day 2. Hopefully you've done the Complete the Square Day 1 problems with the practice, all the work with the notes and the practice answers themselves. They are all on Canvas, and you can get on there to check to see how you've done. Okay, so this is Complete the Square Day 2. You already have this paperwork. It is with Complete the Square Day 1. It is the third page. All right, in order to use completing the square, the leading coefficient has to be a 1. If it isn't, divide everything by that leading coefficient and complete the square as usual. So I could review all these steps for you, but really, once you divide everything by that number, you're going to have the same type of setup. So rather than go through all these steps, I'm just going to show that work. All right, so number 1. Solve the following problems by completing the square. Leave answers in simplest fraction form and or simplest radical form. No decimals. So step 1, divide everything by 6. And we get x squared plus 2x minus 8 equals 0. Step 2, take the constant to the other side. So we will add 8 and get x squared plus 2x equals 8. This is the part where we will add a square to both sides. We have to add it to both sides to keep them equal. Now the reason we add that is because we want this left side, this side right here, to be a perfect square trinomial. To find that number, we take half of the linear coefficient, that is this. We take half of that, half of 2 is 1, and we square it. 1 squared is 1. 8 plus 1 is 9. And now to solve that, I'm going to take this up here. To solve that, I'm going to take the square root of both sides. Take the square root of both sides, and we get x plus 1 equals plus or minus 3. The entire square root is gone. All that's left to do is subtract 1. And we get negative 1 plus or minus 3. So negative 1 plus 3 and negative 1 minus 3. Negative 1 plus 3 is 2. Negative 1 minus 3 is negative 4. And we are done. Now, when we solve this quadratic, our solution is 2 real rational numbers. Is there any other way that we could have solved this quadratic? If yes, which one? Hopefully, you are all saying right now, by factoring. Ooh, by factoring. Yes, anytime. Our solutions are rational. That means no square roots, no imaginary units in it. We could have factored. All right, go turn the page on the back. Solve the following problems by completing the square. Leave answers in simplest fraction form and or simplest radical form. No decimals. So step 1, divide by 2. And we get x squared plus 16x minus 7 equals 0. Step 2, take the 7 to the other side. And you should have x squared plus 16x equals 7. Step 3, we are going to add that box, or that square, to both sides. So the left side could be a perfect square trinomial. We take half of the linear term, half of 16 is 8. So we have x plus 8 squared. Now you don't have to write this down, but I'm just going to remind you. x plus 8 squared means x plus 8 times x plus 8, which is x squared plus 8x plus 8x plus 64. That is x squared plus 8x, plus 16x plus 64. Well, this is the only thing that was there. So we have added that number 64 to make it, for us to call it x plus 8 squared. We delete that, and now we know that 64 goes in here and here. So x plus 8 squared equals 7 plus 64 is 71. Take the square root of both sides, and x plus 8 equals plus or minus the square root of 71. You can't break that down. So all that's left to do is subtract 8. And x equals negative 8 plus or minus the square root of 71. The solutions here are irrational. They are real, but they're not rational. So you could not have factored this problem. Couldn't have factored it to solve. All right, number 3. Let's do this. Let's divide everything by -4 first, and we will get x squared minus 8x plus 16 equals 8. Equals -8. And now we have to move the constant to the other side. Or do we? Because really, this left side is already, if you factor it, x minus 4 times x minus 4, which is x minus 4 squared. Take the square root of both sides, and x minus 4 equals plus or minus the square root of 8. If you break 8 down, that's 2 times 4. 4 is 2 times 2. I can take a 2 out, and there's a 2 left inside. 2 square root of 2. Don't forget that negative comes out as an I. And all that's left to do is add 4, and you get x equals 4 plus or minus 2i radical 2. Those are our solutions, both of which are imaginary because of the imaginary unit. Number 2, both were irrational because of the square root. There we have it. Number 4. It wants us to do this and then solve using the quadratic formula. The purpose of this is to show you sometimes it's easier to use the quadratic formula, and sometimes it's easier to use completing the square. Completing the square here is a little difficult. I'm going to start by moving that 9 to the other side, and I get 4x squared plus 8x equals 1. Now I'm going to divide by 4. And this is 4x squared plus, x squared plus 2x. Now I need to add something here, equals 1/4 plus that same something. So to figure that out, I take half of a linear term, half of 2 is 1, and we square it. Whoa! 1 squared is not. X plus 1 squared. 1 squared is just 1. This equals 1/4 plus 1. Right above, 1 is 1 over 1, and to get a common denominator, that would be 4 over 4. So this is 5/4. So I get 5/4 here. Taking the square root of both sides, we get x plus 1 equals plus or minus the square root of the top is the square root of 5. The square root of the bottom is just 2. All that's left to do now is subtract 1, and we get x equals -1 plus or minus the square root of 5 over 2. And that's it. Okay, now that's a little nasty, but I will show you, in order to get a common denominator here, -1 is the same thing as saying -2 over 2. Plus or minus the square root of 5 over 2. That gives us -2 plus or minus the square root of 5 over 2. That way, the entire thing could be a fraction. But understand that both of those answers are completely acceptable. Now, just so you can see it solved by using the quadratic formula, in this problem, it's got to be set equal to 0, so I am going to subtract 10 first. So if I subtract 10, I need a new color. I'll go with red. I have 4x squared plus 8x minus 1 equals 0. In this problem, A is 4, B is 8, and C is -1. So x equals the opposite of b, plus or minus the square root of b squared. That's 8 squared minus 4 times 4 times -1, all over 2a, which is 2 times 4. Not real sure what happened down here. Why this is written on here. So let's get rid of it. It gives me more room to work with. Get rid of that and that as well. All right. So now, if I simplify things, x equals -8 plus or minus the square root. 8 squared is 64. Minus a negative is plus. 4 times 4 times 1 is 16, all over 8. So x equals -8 plus or minus the square root of, what is that, 80 over 8. So now what I have to do is I have to simplify that 80. Well, 80 is 16 times 5. 16 is 4 times 4. I'm going to stop there because I've got 2 4s. So this is x equals -8 plus or minus 4 square root of 5 over 8. What is left to do? Well, that would be perfectly acceptable, but there is a number that goes into everything on the outside, and that number is 4. So -8 divided by 4 is -2. Plus or minus 4 divided by 4 is 1. Square root of 5 we don't mess with. 8 divided by 4 is 2. And there is our answer, and as you can see, they are the same. This 1 does not have to be written in, but you can if you like to see that as a placeholder. All right, what do we got left? Solve the following problems. Oh, this is your classwork. So you guys can work on this. The problems are on Canvas if you need any help, or if you'd like to see it work through slower. Just check Canvas out and you can see it done with all the work. I wish you all the best luck. Have a great weekend, and I will see you on Monday.